This is Environmental Science 1, Chapter 5 on water. In this portion of the video lecture, we will be discussing our global water needs. When we talk about Earth being a blue planet, there is a lot of water on the surface of the Earth. In comparing water to land on Earth, the Earth is about 71% water. And of that Earth's water supply, the majority of the water on the planet is salt water in the form of seas and oceans. So only 3% of our water supply on the planet is fresh water. When we talk about human needs for water resources, if we think about that 3% of fresh water that is available on the Earth, over 3/4 of that small percentage is water that is in a frozen state, which would be our polar ice caps in the North and South Pole. Much of the Arctic and Antarctic is locked up in ice permanently all year around. So when we talk about, again, human water needs, we need usable fresh water. We do not consider ice as a usable water source. So of that 77% of water that is frozen solid, only 23% of that original 3% of fresh water is available for our human needs. When we talk about drinking water, there is a couple of different sources where that comes from. We can have surface water, freshwater resources. So that would be water found in lakes, rivers, and streams. We can also take a look at what's called the watershed, which is the entire area of land that's drained by a river. And so all of the creeks and streams and smaller tributaries will flow into one main watershed. For example, the majority of the United States is in the Mississippi River watershed, of which, of course, Minnesota is a part of. So our surface water resources come from the Mississippi watershed. When we discuss our global water needs, and because fresh water is such a precious resource, we can have some controversy in dealing with our freshwater, surface water resources. For places in the United States that are a little drier than average, places in the southwest part of the country, places like Southern California, Arizona, New Mexico, places in Texas, can actually fight over water resources. And with the amount of population that is down there, which is a very rapidly growing part of our country's population, fresh water, usable, drinkable water is going to become, in the future, a very kind of a premium resource for states to fight over. Countries will also fight over water resources. In different countries where we have places on the planet where the water and the river is flowing through perhaps many different countries or more than one, we can have some controversy as to who owns the water rights for that river, who can divert those water resources for the people of that country or of that region. So because fresh water is at a premium and populations are increasing, we are going to have a higher demand for good, clean, usable drinking water. And as usual, countries that are in the developing area, as far as places in Africa and some places in India and Asia and South America, are really starting to learn how to take the water resources that they have and have it be more usable for the people of their country or their region. One of the ways that rivers can cause a little bit of controversy is the fact that in some cases we dam up the river. So a dam is a structure that restricts the flow of water downstream from a river. There's many different reasons that we could do this. We could dam up a river for ecological reasons. We could dam up a river for perhaps political reasons. We could dam a river for basic human needs. Behind the dam, so upstream from the dam, is what we call a reservoir or an artificial lake. Hoover Dam, for example, in Nevada, we have Lake Mead that is upstream of the Hoover Dam, and that is still in the process of curing or having the cement actually fully and solidify and be structurally sound. So the Hoover Dam is one of those examples where we have our reservoir or artificial lake behind that dam. So the water in that reservoir could be used for purposes of drinking water, irrigation, which is using water to water crops in areas that do not get a lot of natural precipitation. In some cases, reservoir water can be used in manufacturing. In some cases where we are making products, there is water from that reservoir that can be used either in a cleaning process or in the actual making of products themselves. We can also kind of use the power of Mother Nature and gravity to generate electricity. So falling water from that dam can turn turbines to generate electricity. Dams in some cases are necessary, but they can disrupt ecosystems both above the dam, upstream from the dam, and below the dam. When dams are constructed, the water is often diverted into different places, and wildlife that previously used that river or stream for a resource may return the next season to not find it there anymore. So fish that use these waters to live and travel in, sometimes when those get diverted, that can cause some disruption as well to the aquatic life that is in the river. Another big water resource for us that is usable and drinkable is in the form of groundwater. Aquifers are groundwater that it's like a kind of an underground river. The water is locked underground in rock formations. It gets there due to surface water kind of slowly percolating down through all of the different layers of soil. But it is a very, very slow process. In order to have nature create an aquifer, that could take anywhere from 100+ years up to 1,000 years, depending on the precipitation of the area, its topography, or the lay of the land. Groundwater aquifers are not made overnight. So the recharge zone is the area of land from where this groundwater originates. And so this is where the water is essentially flowing underground, much like a river. So here we have in the diagram an example of an aquifer. The level of the aquifer is always at the same level as any surface water present in that area. Just like anything, okay, gravity pulls things down to its lowest point. So any surface water, a lake, river, stream, pond, that is the lowest point of the water table. And so when land gets thicker, then goes above the surface water, then we can take a look at where that water is flowing underground. What is occurring, not just in this country, but in many countries, is that aquifers are running low. So we pump water out of the aquifer, and if it's pumped out faster, then it can be replenished. The water levels will drop, which means that you need to drill a deeper well to get down to the water in the aquifer. So aquifers are replenished by kind of natural cycles like the spring thaw, spring thunderstorms, and the like. So every time water is going to be present on the surface, it's going to work its way down through the soil and then be held in that aquifer. But again, if we're pumping it out faster than Mother Nature can replace it, we'll need to keep drilling a deeper well to reach the water. So what are we going to do as far as our problem with a water shortage? Some countries in, for example, the Middle East use a process that's called desalinization, which basically means that you're taking the salt out of the water. The reason why you can't drink large quantities of salt water is because it's very bad for your body. And so taking that salt out can help make that water usable and drinkable. Here's one way that we can desalinize water. Distillation is where we would use heat to evaporate all of the fresh water out, and what is left is the salt. Distillation is a very, very expensive process. There are some new technologies being developed in this area that may help reduce the cost of this process, but it is one of the more expensive ways to get salt out of the water. Another way that we can do this is with a process called reverse osmosis. If you remember from 10th grade biology, osmosis is the movement of water from where there isn't very much, or where there's a lot of water, to where there isn't so much. So reverse osmosis is using pressure to actually push water through a semi-permeable membrane that has pores in it small enough for freshwater molecules to get through, but not salt molecules. And so it's kind of reverse pushing the water and leaving that salt behind. A third option, which is kind of a rather interesting one, is because, a lot of our fresh water is frozen. There have been countries that have been known to actually tow icebergs or tow chunks of ice to peoples that need fresh water. It's not the most efficient process. You can imagine that, ice melts eventually. Also, it disrupts polar ecosystems when you remove those permanent chunks of ice. Also, transporting it is an issue. On a small scale, this could be done, but it would not help for countries that would need a very large drinkable water supply. So, of course, the third option is making sure that we protect the water that we do have, conserving it. There's lots of different ways that we can do this. Super simple. You can even, shut off the faucet while you're brushing your teeth. In some places of the country, you can make what's called an alternative lawn. You can have rocks or pea gravel and type of landscaping with different types of plants that really don't require a lot of natural water resources. Can water our lawns at nighttime. A big waste of water that we have is actually every time you flush the toilet. About 45% of the water that people use daily is from flushing the toilet. Low flow faucets and toilets could help that as well. But basically, we need to conserve our usable fresh water that we have because the 7 billion people on the planet are going to need to share those resources. This has been Environmental Science 1, Chapter 5, Part 1 on our water resources.